So bright fringe xn equal to n lambda d by d or n beta, right? So fifth, what is required? Distance of fifth bright fringe, that is x5 is equal to 5 into beta, or 5 into beta value already found out here, that is 3.75 into 10 power minus 4, and your answer is 1 point, check the answer, 1.87, somewhere like that you will get 1.87 into 10 power minus 3 meter by the calculation. Fine. So next, in the same question, one more sub question is there, fourth dark fringe. That means we are supposed to find out, this is B, this is A. Okay. Distance of fourth dark fringe. Distance of fourth dark fringe. So how to do that? Let us see. So equation is fourth dark fringe. So xn is equal to 2n plus 1 by 2 beta, correct? Formula. Hope you remember this. Hope there is no confusions in this. 2n plus 1 by 2 lambda d by d, or directly beta I have taken. But here n value, how much has to be substituted? 3, correct? Because n2n plus 1 is given. So the other day I have explained you all this. So answer is x4 equal to 2 into 3 plus 1 by 2. 3.75 into 10 power minus 4. So x4 is equal to, check the calculation, your answer has to be somewhere around 1.3125. Okay, 1.3125 into 10 power, and this is minus 3 meter. Okay, this is the calculation. Check your answer. Fine. That is all about question number 8. Let us move on to the next question. Question number 9. Question number 9, let us go through it. So question number 9 is, in Young's double slit experiment, the separation between slit is 0.5 millimeter. Separation between the slit, that means small d, slit width, so 0.5 millimeter. Interference pattern is obtained on the screen at a distance of 1 meter. So capital D is also measured 1 meter. From the plane of the slit. Slits are illuminated with lights consisting of 2 wavelengths. See, here 2 wavelengths are being used. Okay, one after the other. Okay, 2 wavelengths are used, one after the other. That is, one lambda 1 is equal to, how much is that? 4000 angstrom, and after that one more it is used, 5000 angstrom. What is the linear separation on the screen between fifth dark fringe of two pattern produced by two wavelengths? That means when two different wavelengths are used, different separation, what is that called? Fringes are framed, correct? Now they are asking, when you use first wavelength lambda 1 and see the pattern, fifth bright, correct? Sorry, dark fringe. Fifth dark fringe x5 is equal to 2n plus 1 by 2 lambda d by d. That will be placed at one particular value. Okay, turn off 4000, turn on 5000 angstrom source. Now x5 will be having some value slightly different compared to the previous one. Now those difference in the value is there, right? That linear separation is how much? That is a question. Hope you understood the question now. Now what I do here, nth dark fringe it is. So x5 or just x I will take. Xn is equal to, formula we have to write, very important in the examination. So lambda d by d for fifth dark fringe, n is equal to 4. So now what I do is, x5, okay, for, that means x5 dash I will take, okay, that means for first case, for first wavelength, is equal to 2 into 4 plus 1 into first case, how much is the wavelength? 400 nanometer or 4000 angstrom into d 1 meter divided by, here divided by 2 is there, okay, small d is 0.5 millimeter, 10 power minus 3, and check the answer. Fifth dark fringe for the first wavelength x5 dash I have taken is equal to, the answer is 3.6 millimeter, okay, 3.6 millimeter. Now what we are doing, we are using the same experimental setup, and again we are performing the experiment for wavelength 5000 angstrom, okay. So that is, I will take x5 double dash equal to 2 into 4 into, sorry, 2n plus divided by 2 lambda 5000 angstrom of 500 nanometer or 5 into 10 power minus 7, whatever is easy for you take, into lambda d by 0.5 10 power minus 3. So x5 double dash, what is the answer? You will get somewhere around 4.5 millimeter, okay, 4.5 millimeter. Therefore we got to know, when you apply wavelength 5000 or 500 nanometer, you will get fifth dark fringe at one particular distance from the central maxima. Like that, in case of 400 nanometer, from central maxima x5 will be at one particular distance. So variation we got to know, correct? Here it is 3.6, there it is 4.5 millimeter. So that means, what is the linear separation now? Difference between them. So linear separation between them is what? x4 5 double dash minus x5 single dash equal to 4.5 minus 3.6 into 10 power minus 3. So answer is, so this is 9, correct? Yes, of course. 0.9 into 10 power minus 3 meter. That is all about question number 9, students. Okay? Hope you understood this. Looks lengthy and slightly complex. Don't worry, if you practice such kind of questions, it will help you a lot for competitive examination point of view also. These are something like warming up kind of exercises. Okay, so this will help you. So nothing to worry. For board exam also it is useful. For competitive examination also, this will give you some of the knowledge. Okay, fine then. Next, let us go for question number 10. So question number 10, let us see. A beam of light consisting of two wavelengths. Single beam of light, okay, two wavelengths are there, 500 and 400 nanometer, is used to obtain interference fringes in Young's double slit experiment. The distance between the slit is 0.3 millimeter, 0.3 millimeter. Distance between the slit and the screen is 1.5 meter, 1.5 meter. Compute the least distance of the point from the central maximum. Compute the least distance from the central maximum means from the center of the screen, that means fringe width or the pattern, where the bright fringe due to both wavelength coincide. From the center, many bright fringes are there. Here mixed up because two different wavelengths are there together. Together they are forming fringe width, that means fringes. So they overlap on each other. But they are asking, compute the least distance from the point from the central maximum where the bright fringes due to both wavelength that means will coincide. So you have to search it, like where they may coincide. That is a question. Okay. So let us try to find out that. Okay, bright fringe it is given. So general formula, distance of nth bright fringe, distance of nth bright fringe given by xn equal to n lambda d by d or n beta, correct? Yeah. So let us take, let x be the minimum distance from common center of bright fringe. Okay. So what we do here, at which nth bright fringe, okay, at which simply I am taking like nth bright fringe of lambda 1 coincides with mth fringe of lambda 2. See, like this I have taken. Okay. So for that what I do right now is, distance is same, right, for both, because they are coinciding. So when they coincide, from the center to the point of coincidence, distance is one and the same, because that is why they are coinciding, right? So I will take x n is equal to, so value will be like n into lambda 1 divided by So equal to m into lambda 2 d divided by d. Hope you can make out now what is that. Xn is same for both because they are coinciding. So lambda 2, lambda 1 for different wavelengths. Okay. So now what I do? I will try taking the ratios. Okay. So n by m, because lambda 1, lambda 2 we know. Lambda 2 by lambda 1. So what is n by m? Lambda 2 means is given, I think. Yes. Lambda 2 is 400. 4 into 10 power minus 7 divided by what? Lambda 1 is 500. 5 into 10 power minus 7. So n equal to 4, m equal to 5. Like this we get when we take the ratios. So value of n and m we got to know. Now let us apply a normal formula. Therefore minimum, I am calculating here, distance from, hope you can see that, minimum distance from central maxima or central bright fringe, okay, bright fringe, sorry, where they coincide. So I will substitute in one of the formula, whatever it's required. So distance I am finding out, n value 4, lambda 1 value 500, 10 power minus 7, lambda d value is 1.5, small d 0.3 milli. Check the value. Looks very complicated, kind of numerical, but it's not. Your answer should be, check, okay, 1 centimeter finally. Okay. So answer should be finally 1 centimeter. Hope you understood it very clearly without any doubt, I hope. So let us move on to the next remaining numericals. These are kind of lengthy as well as tricky numericals, but if you practice well, no, you will get a lot of knowledge which may help for your solving numericals in your competitive examination. That's why. So question number 10 is over. Question number 11. Question number 11 is, in a double slit experiment using light of wavelength 600 nanometer, okay, in a Young's double slit experiment, wavelength of 600 nanometer, the angular width of fringe formed at a distance of, okay, angular width is given, theta. Hope you remember all this. That is theta equal to 0.1 degree. What is the spacing between two slits? That means small d equal to how much you have to calculate. So you know the formula already I have mentioned to you people. That is angular width theta equal to lambda by d. Correct? Hope you remember this. So d equal to what? Lambda by theta. So how much is lambda now? Lambda is 600. 600 into 10 power minus 9 or 60 into 10 power minus 7 divided by theta value 0.1 degree means how much it is. Okay, be careful here while substituting. I will do conversion. Theta equal to 0.1 degree. It is also equal to 0.1 into pi by 180. Convert it first. Okay. 1.764 10 power minus 3 radian you will get. So 1.764 into 10 power minus 3. The answer is, check the answer, D value is 3 point, I'll directly write the answer, 436 into 10 power minus 4 meter. This is the answer for question number 11. Okay, hope it is clear. This is the conversion I have shown you people in order to convert from degree to radian for calculation purpose. Next one, look at there, a slit of width. I will erase first, we require more space for this, that is why. It's about Fraunhofer diffraction. All the type of numericals are present here, okay. Question number 12. A slit of width 0.05 millimeter. 0.05 millimeter receives plane wavefront of a light of monochromatic source emitting wavelength. That means wavelength is 589 nanometer, okay. Calculate angular position. Calculate angular position, that means theta equal to how much? Position of what and all? Second minimum sub question B, third secondary maximum. Okay, so let us go for first one. Okay, so first one, what is that? For minima, d sine theta equal to n lambda. Hope you remember the formula from our diffraction concept. For second minimum, for second minimum, n equal to 2 itself, nothing to worry there, okay. Therefore 0.05 d value into 10 power minus 3 d sine theta. Sine theta, how much is that? Don't know. Sine theta equal to n lambda. N is 2. Lambda is how much? That is 589 into 10 power minus 9. So theta is equal to, your answer will be somewhere around 1 degree 21 minutes. This is you have to do using your Clark's table, trigonometric table. Check out. For minima, you will get 1 degree 21 minutes. Angular position, okay. So secondary maxima, okay. Sub question B. For secondary maxima, which secondary maxima? Of course, given there, third secondary maxima. So third secondary maxima is mentioned here. So n equal to 3 directly I will write. So what is the formula? That is given by d sine theta equal to 2n plus 1 by 2 into lambda. Like this we get the formula, correct? So this is 0.05 into 10 power minus 3 sine theta is equal to 2 into 3 plus 1 589 into 10 power minus 9 divided by 2. So here also take the sine inverse, all those things. Your answer has to be 2 degree 21 minutes, something like this you will get. Okay. Hope you are able to understand all this. Next, question is, assume light of wavelength 600 angstrom is coming from a star. What is the limit of resolution of telescope whose objective has diameter of 100 inch? Okay, so in inches and all it is mentioned here. Let us see what is the way of solving this numerical. Okay, so question number 13. What is to be found out here? What is the limit of resolution? So limit of resolution means, of course, is a telescope. So telescope limit of resolution d theta equal to 1.22 lambda divided by d, correct? Yes. So limit of resolution of telescope you have to find out, where objective has diameter of 100 inches is given. So inches means in meter how to write down. So we'll convert, okay? 100 into 2.4 inches. Sorry, centimeters, okay? 54. That means 1 inch means 2.54 centimeter. That is why. So you will get 2.54 meter, right? Diameter. So limit of resolution d theta equal to 1.22 into lambda value is given in the question. That is equal to, how much is that? Lambda value 6000. That means 6 into 10 power minus 7 divided by small d value. D value is, yes, of course, 2.54. Finally, d theta is equal to 2.882 into 10 power minus 7 radian you will get, okay? Check this. We have solved one numerical which is actually from telescope concept, okay? Limit of resolution. Question number 14. It's about Brewster's angle. Look at there, student. What is the Brewster angle for air to glass transition? Yes, what is that? Air to glass transition means n equal to, so n equal to what? Tan theta p. So theta p equal to tan inverse of 1.5. So theta p equal to, check the answer. Very simple. Answer is somewhere around 56 degree 15 minutes. Okay, students, simple it is. Brewster's angle, finding out that. Question number 15. Polarizing angle of optical instrument medium is given. Theta p is given, that is 56 degree. Calculate critical angle. So, of course, critical angle means, what is that? Equal to tan theta p. So, n equal to tan 56 degree. So, n equal to how much you will get, 1.48. 1.486 you will get, okay? Check. And n equal to 1 by sin c, correct? So c equal to what? C equal to sin inverse of 1 by n. Calculate, you will get the answer, okay? This is left to you. Critical angle c equal to sin inverse of, okay?